So today we're looking at solving inequalities by using addition or subtraction. If I have a number a that's greater than b, it's also going to hold true that a plus c is greater than b plus c. And to look at an example, I know that 5 is greater than 3. If I add 2 to both sides, 5 plus 2, is it still greater than 3 plus 2? Well, I get 7 is greater than 2, so that checks out. Anytime I add a number to both sides, it's still going to work out for that equality sign. And sorry, that should be 7 is greater than 5 because 3 plus 2 is 5, not 2. But it still does hold true. It also works if a is less than b, that a plus c is going to be less than b plus c. As you can see, we know that 3 is less than 5, and if I did the same thing to both sides, I would get 5. It's less than 7. That still holds true. So let's look at how we would apply that. Let's say I have t minus 45 is less than or equal to 13. What I'm going to do is I'm going to add 45 to both sides to isolate that t, just like I would do if I were solving an equation. We would end up with t plus 0 is less than or equal to 13 plus 45, or 58, meaning that all numbers less than 58 are going to work for that inequality. Just to make sure that holds true, let's try a number less than or equal to 58. Let's try 50. Does 50 work? We have 50 for t minus 45. Is that less than or equal to 13? Well, 50 minus 45 is 5, and that indeed is less than 13, so it holds true. Any number less than or equal to 58 is going to give me a correct solution for that inequality. So let's say I have something like s plus 19 is greater than 56. Just like the addition property holds true, the subtraction property will as well. If I subtract 19 from both sides, I'm going to get s is greater than 37. And we can actually graph that on a number line. We make a number line. We have 37 here. Obviously 36 would be to the left. 38 would be to the right. We're going to put an open circle here. Notice 37 is not included. S has to be above the value 37. So we're going to leave an open circle showing that 37 is not included. And then we're going to shade everything greater than 37 up through infinity by showing that the right side of our number line is shaded. Alright, so let's say we have variables on each side. Something like 5p plus 7 is greater than 6p. Just like with the equations, I want to get all my like terms on the same side. So I'm just going to go ahead and subtract 5p. Mainly I do that because 5 is less than 6 and it's going to leave me with positive numbers. So I'm going to get 7 is greater than 1p or just p. Meaning the same thing as p is less than 7. If 7 is greater than p, we know that p is less than 7. It's usually best to put your variable on the left side. So that we have 7 on our number line, 6 is going to come before it, 8 will come after it. Again, it doesn't include that 7, so we're going to leave an open circle there, shading everything to the left. This p is less than 7. So that concludes our discussion of solving inequalities with addition and subtraction.